So our next section is 7.3, adding and subtracting rationals. The key to this is we have to have a common denominator in order to add or subtract. So if we don't have that common denominator, then we're going to have to come up with it ourselves. So for my first example, I have 7 over x plus 3 over x. And because there's an x on the bottom for both of those, we can just add them and we get 10 over x. My next one, I have 5x plus 4y over x minus 3y minus 2x over x. So again, both of these have an x on the bottom. Here I have a subtraction. So when you have a subtraction, it changes the sign of everything afterwards. So I'm going to make this a plus, make that a negative 3y, and a positive 2x. Now when I go to combine like terms, I know all my signs are right. So I have 5x there and a 2x there to add up to 7x, and I have a 4y and a minus 3y, so that gives me plus y all over x. My next example, I have y squared over y minus 1 minus 1 over y minus 1. This is a subtraction, but because there's only one term, I don't really have to worry about distributing like I did in the previous one. So again, my denominators are the same. I can add or subtract the numerators, I should say. So y squared minus 1 over y minus 1. Now in this case, I can actually simplify it. My numerator is a difference of two squares, so it factors to y minus 1 times y plus 1. And then I have that y minus 1 in the bottom. So these factors are the same. They simplify to a 1. And my final answer is just y plus 1. So again, with a common denominator, it works out really well. We can just go and combine those numerators. So how about if I do not have a common denominator? I have 5 6 plus 7 eighths. So I'm looking at the bottom numbers, 6 and 8. And my LCD would be 24, because 6 times 4 is 24, and 8 times 3 is 24. So I usually write out my problems vertically, so 5 6 plus 7 eighths, and I put what that 1 is that I'm going to have to multiply to get them the same. So we said the denominators are 24, and now what am I missing? So 6 times what is 24? That would be 4. And because I had to put a 4 on the bottom, I have to put a 4 on the top as well, because I'm only multiplying by something that equals 1. So 5 times 4 gives me 20. Down here, I'm missing 3, because 8 times 3 is 24. So again, I have to put a 3 on top, and that gives me 21 over 24. Now that they're the same denominators, I can combine them, and it combines to 41 over 25. So we do this with real numbers, and we can do the same thing with variables. So I have 7 over mn plus 4 over mn squared. So what do they have in common? They both have an m, and they both have at least one n. But this one has another power of n that we haven't accounted for. So my LCD would have to be m times n squared. Then I'm going to do the same thing vertically. 7 over mn plus 4 over mn squared. And we said the LCD is mn squared. So what am I missing for this first one? Well, I have the m and I have one n, but I need another one. So I'm multiplying that by n over n. The bottom one, I have everything I need, so I'm just multiplying by 1. So I get 7n over mn squared plus 4 over mn squared, and now I can combine them. So my numerator is 7n plus 4 over mn squared. For my next example, I have 3 over y plus 2 over y minus 3. Well, I can't turn a y into y minus 3 or vice versa. They're not multiples of each other, so they don't have any common factors. They're considered relatively prime. So my LCD is just multiplying those two together. So we have 3 over y and 2 over y minus 3. My LCD is y times y minus 3. So I'm putting those on the bottom. And these problems are addition, so I haven't had to worry about distributing anything. So this first one is missing the factor of y minus 3. The second one is missing the factor of y. So I can go ahead and distribute through the top, and I get 3y minus 9. And down here, I get 2y. And now that they have common denominators, I add the tops, and I get 5y minus 9 over y times y minus 3. I can't factor the top, so there's nothing I can simplify. So that's as far as I can go. Alright, my next one, I have 2a minus b over 6a plus 3a plus 6b, sorry, minus 4a plus b over 5a plus 10b. So they don't look like they have anything in common, the denominators, but I need to factor them. So I'm going to factor the denominators, and I also want to make sure this one is a subtraction, so when I go to write it vertically, this is going to change sign. So it's going to become a negative 4a and a negative 4b. So I don't want to forget to do that either. So let's factor these denominators. This first one has a common factor of 3, and that would leave me a plus 2b. This one has a common factor of 5, and that would leave me with a plus 2b. So they have this in common. So I know a plus 2b is part of it, and then I have a 3 here and a 5 here that's not accounted for. So multiply those together and I get 15. So our LCD is 15 times a plus 2b. So I'm going to write these vertically. So 2a minus b, and I'm going to write it in factored form so I can see exactly what I'm missing. Alright, so we'll have to multiply by some 1s, and we know on the bottom it needs to be 15 times a plus 2b. So here, all I'm missing is the 5. So I'm going to multiply this by 5 over 5. And down here, I'm missing a 3. So I'm going to multiply that by 3 over 3. So when I multiply them, I'm going to distribute right away. 2a times 5 gives me 10a. Negative b times 5 gives me a negative 5b. Down here, I get negative 12a and negative 3b. Okay, now we can combine our like terms. So I'm going to put these together, and I get negative 2a minus 8b over 15 times a plus 2b. Now I'm not really sure if anything will simplify, so I'm just going to pull that out really quickly. The factor of negative 2 out, and I'm left with a plus 4b. So no, it doesn't match because this is an a plus 4b and that's an a plus 2b. So I can't simplify any further than that.